Okay. All right. So now we have to factor each of those groups individually. So let's do that. All right. Now, as you can see here, from the first group, 2x squared plus 4x, right? Well, again, let's find the GCF and let's factor it. Factor it out, I should say. So we have the smallest power of x is 1, right? So m is 1. 2 is a factor of 4. So 2 is the greatest common, is b the greatest common term. Not only that, okay? B times x to the m. Yep. Someone have a question? It's not. Okay. B times x to the m then is 2 times x. So we factor that out. We put it in front, and you have to divide to see what's left over, right? But when you divide into each term in a sum, right? That's what you have to do. You divide into each term in the sum, right? So we get 2x times 2x squared over 2x. That's just x. 4x over 2x is 2. Okay, that's good. And so from here, we have the first group factored. Now for this one here, I didn't say what the GCF is, but hopefully you can see that it would be 1. Mostly because we have a non-zero constant term. That tells you right away that m has to be 0, right? As we saw before earlier in the course. Not only that, the coefficient of x is -1. And we saw that if the coefficient is 1, if a coefficient is 1 or -1, that forces the b to be 1. Because the only factor of it is 1. But we have to factor out a negative at least. So let's factor out -1. So what do? We put it in front, and then we divide, right? Divide into each term, and we get this. Now notice also at the factoring in the parentheses, we have the same thing, x plus 2. That's good. That's what we want. Okay? That's what we want. So altogether, we get this thing, this trinomial, degree 2, is equal to this. And then that common factor, x plus 2, we take it out. It comes out in front. What's left over? We have 2x plus -1, which is this. And then we had 3x from earlier, right? That was the first thing we factored out. So altogether, when it's factored completely, we get this, equal to 0. So again, what do you do next? You set each factor equal to 0. So 3x we set equal to 0, right? And you just divide by 3, you get x has to be 0. X plus 2 you set equal to 0, but you just solve for x, subtract 2 from each side, you get x is -2. And 2x minus 1, same idea, right? You set that equal to 0, solve for x. You add 1 to each side, right? Because you want to get x all alone. So you get 2x equals 1. And once you do that, you divide both sides by 2. You get 2x equals 1, but you want x all alone, so we divide both sides by 2. And doing that, we get x equals 1/2. So those are the 3 solutions. Are there any questions on that? do another one. Well, oh, sorry, not another one. Well, sort of. We could use the quadratic formula here. I mean, not initially, right? Because it's degree 3. But as we saw, if you were to factor out the GCF, you will have a quadratic, right? In other words, from this big product here, right? As we saw in the previous slide, we get this has to be 0. Okay, we have to solve that. I mean, from 3 times x equal to 0, we get x must be 0, just like before. Okay, so after factoring out 3x, we get a quadratic we can work with, but we can solve this equation using the quadratic formula. Okay? Remember, this is the quadratic formula. If you have this equation you want to solve, this is the formula that gives you both solutions, if they exist. I mean, if what's under the radical here, the b squared minus 4ac, if that's negative, then you don't have any solutions in this class. Okay, so from here, we get a is 2, b is 3, c is negative 2, just by comparing. So the formula gives us this. That's not enough, right? We can keep going. So we get negative 3 plus or minus the square root of 3 squared minus 4 times a times c over 2 times 2. So that's negative 3 plus or minus the square root of 9. That's minus negative 16. So we get 9 plus 16 over 2 times 2, which is 4. 9 plus 16 we know is 25. So we have this square root of, they want to go too fast. What's the square root of 25? 5. And so we get the two solutions are negative 3 plus 5 over 4, which as you can see is just a half. The other one is negative 3 minus 5 over 4, which is negative 8 over 4, which is negative 2. So again, along with this solution, we get these as our 3 solutions, which is what we got before, so that's a good sign. All right. Any questions on this? Here we go. So I was going to do this one. I mean, I'll do this slide, I guess, but I was also going to solve it by factoring. But the factoring part we'll do next time. So anyway, for this equation, we can use the quadratic formula. But remember, you can't use it immediately, though, right? You want it in the form of ax squared plus bx plus c equals 0. That's the form it has to be in. And we don't have that here. No problem. We just get it in that form, and we can do that by subtracting 11x and 6 from both sides. And that's what I'm doing. Okay. So we have 7x squared minus 11x minus 6 equal to 0. But now we can use the quadratic formula. We have a is 7, b is negative 11, c is negative 6. And then we plug it into the formula. We get all this minus 11 plus or minus the square root of minus 11 squared minus 4 times a, which is 7 times negative 6 over 14. And now it does take a little calculation. You end up getting 11 plus or minus the square root of 289 over 14. That turns out to be a perfect square. It's actually 17 squared. So we end up with this. And then you get 11 plus 17 over 14 and 11 minus 17 over 14. Here I reduced it to negative 3 over 7. You don't have to do that, though. And those are the only two solutions. Okay, I think we're out of time now, so we'll stop. Okay.